A traffic intersection, a Hollywood movie set, the outside of an airplane. It's hard to imagine any common ground between them until you flip a switch, a light switch. Traffic lights, movie lights, and aircraft lights are all made of the same type of special glass. It's called technical glass. Borosilicate glass has a low thermal expansion and is very durable. It's used in high-temperature applications and when abrasion resistance is important. It begins with a mix of silica sand and chemicals called batch. Workers shovel the batch and recycled glass called cullet into a pot furnace where they melt for 2 days. A variety of colorants are added to make hundreds of different colors. Next, it's on to the molding process. Workers heat a ring and transfer it to the top of a mold. Then they twist and turn a stick called a punty to gather some melted glass and carefully string it in the mold. A plunger squeezes the molten gob into shape. The glass solidifies in seconds. This glass lens is used as a landing light cover on an aircraft. They extract it from the mold for a quick inspection, any imperfections, and it gets recycled. If the lens is acceptable, it's held in a forming device to finalize the shape. The burner maintains the proper temperature of the ring. Once formed, the lenses are cooled in an annealing oven, which relieves unwanted stress in the glass. This circular mold makes theatrical and landscape lighting. Again, a gob of molten glass is dropped in the mold and the plunger is depressed, forming the lens. Heat-resistant tongs enable workers to handle the hot lenses. Red and yellow lenses need a high-temperature anneal for the color to appear. This is called striking. Back on the molding line, special tools are used to ensure this aircraft lens maintains its shape. A quick spin on a light wheel illuminates any defects. After a trip through the annealing leer, the lenses are ready for further processing. The molding process for larger lenses can be more complicated. This large convex lens requires several gobs of molten glass, placed carefully on top of one another. The plunger enters into the molten glass, forming the lens. Deep ridges located in the plunger of the mold create the circular prisms on the glass lens. Within seconds, the lens is ready for extraction and inspection. Using heat-resistant mitts, workers scrutinize the glass from every angle, checking for small fractures or imperfections in the glass. Next, they inspect for flatness, using a paper-thin plastic feeler. If it slides underneath, the lens is warped and unacceptable. They check the glass thickness in many locations using a calibrated thickness gauge. Any major defects, and they discard the lens. In the factory's finishing shop, they use a diamond saw to slice away excess glass around the periphery. A special sanding belt is used to smooth the surface to perfection. Then, with a cloth buffing wheel, they polish the glass to a shine. At last, the final inspection. Using calipers, they measure the lens's ridged edge, called the flange, to make sure the dimensions are correct. Producing such a colorful assortment of technical glass takes a lot of work, but at least there's light at the end of the tunnel.
slow up, no I don't take shit, I got no love